Can you hear me?
Yes.
Yeah. Stream Analyze, we are part of the FREEPORT project. Yeah, what are we doing here and what are we doing in general? Yeah, we make an easy to use infrastructure and tools for developing, deploying, running, and managing analytical and AI models on massive fleets of distributed edge devices. That's a mouthful, but you're sort of up to speed on all these words already, so this should be comprehensible. We also have some background in research. In fact, anecdotically, I should mention that some of our unit tests and some of our core engine code is actually older than some of our employees. So it all started at Stanford, it continued in Linköping and then in Uppsala. I was coming in at 2005 when you had the Kungsbacka discussions and did my PhD project for a few years. Back then, we did a lot of data streaming and queries over those data streams, especially studying how can we do this in a scalable fashion when we have a lot of streams and very complex analytics. So that is one of the results we sort of carry with us also today. Another thing that has been important for us is this no compromise on the software, on the core software. So the software has a very small footprint and rather high CPU efficiency and so on. And this is also something that seems to be useful in an edge setting. So let's look at the platform that we have now. And going from left to right, SE Engine, our core software, is installed on the assets such as vehicles and gateways, what have you. Potentially also onto individual microcontrollers, as illustrated on the far left. So we could actually run on ARM, Cortex-M or RISC-V and really small processors. And a fleet of assets will thus have a large number of SE Engine instances installed. Each SE Engine will connect with our management system, the SAPs, the SE Federation Services, typically enterprise cloud or on-prem, depending on customer choice. And then SE Engine on each edge will retrieve models and queries to be executed on the edge. And results will be streamed to Federation Services or directly to any third-party integration, such as MQTT or what have you. Users interact with a fleet of edge devices using the SA Studio, which is either a Visual Studio Code plugin or a web page that users can interact with. Then they basically can talk to the vehicles and ask them for, what are you guys doing now, actually? Basically querying them like you would query a distributed database. SAPS also has support for lifecycle management, including testing, release and deployment of models. So we do support the ML workflow here as well. In addition to SA Studio, other external systems may also be plugged into SAPS. So now that you have this high-level description of the platform, let's talk briefly about cybersecurity because it's also mentioned in the project description. We do most of the cybersecurity here according to the enterprise standards, including all communication to and from SAPS is encrypted using MTLS. Other encryption mechanisms may be plugged in. We do have different authorization levels also on edge devices so that not everyone can do everything. And we also interact with external identity providers such as Auth0 and MS Entra and so on. A few words about SA Studio, the user product. Here's a screenshot of it. So I won't spend too many seconds on this because you're going to look at it live in a bit. Now that you know everything about the platform, let's look at what was the specifications that once shaped the platform and are still shaping the platform. So what are the considerations when doing edge analytics? We have three observations here. Mobile data is expensive. Cloud data is expensive. There are data privacy considerations. Personal data needs to stay at the edge, preferably, rather than being transmitted into data centers. I'm sure you can come up with other arguments for edge processing, but these are 3 arguments for edge processing that we often come across. So then the question is how to do edge processing, and how should a user sort of learn about the data and get an intuition to it before starting to make all these models. How to do the edge processing? Well, you can't know upfront what data is there. So it is very useful, actually, to be able to talk to the edge units and edge devices in order to learn what is going on here. And I'm betting my life on this guess that your first model that you will deploy to your edge will not be your final model. So you will need to iterate your models. You can kill me if this is not the situation. So then the question is, how would you like to iterate your models? Well, we have this see, understand, model, automate sort of ladder, where you look at the data, you try to understand the data, try to make sense of the data, make a model of the data, and eventually you want to automate whatever predictions you do of the data, right? And an important observation that we believe in is that interactivity will help the understanding. The faster turnaround cycles you can have, the faster you will improve your models. It sounds like a law of nature, almost, but we haven't proved it yet. This is something we believe in. So a consequence of that is actually we want to take the interactive data platform to the edge, much like you do a Power BI interactively. You will want to take Power BI to the edge. That is not a product that existed before we made our nice product. So we think we do have some kind of competitive edge here. And in addition to that, model lifecycle management, including testing, validation, and so on, is important here. So that is also something that we consider important to support in a platform like this. Special infrastructure considerations, including edge software footprint. All edge devices are resource limited. So you need to be sure that you don't take up all memory. You also need to be sure you don't take up all CPU. So processing efficiency is important. Network security, we already talked about that. Network performance, well, yeah, you will expect that network connectivity will be on and off. And you will expect that network performance is going to be spotty. So an edge analytics platform will have to somehow relate to this fact. And especially if you want to be interactive, this is important. And this goes down into details such as how often will I want to flush my network buffers, for instance. So there is a lot of detail in this. And what kind of encryption or what kind of compression will I want to apply on my data in order to minimize the amount of network transmission while honoring the processing efficiency. So this is all a non-trivial optimization exercise. And then we also figured that interoperability is important. You want to be able to quickly connect new sensors. You want to be able to obtain canvas messages with minimal effort and so on. You also want to integrate with your well-known data center infrastructure, including MQTT and databases, and the independence. The only thing we need for our platform to run is a C compiler. That was the sales talk. Now I'm done with that. It didn't hurt so bad, and hopefully it sort of shed some light on how to build a platform like this. So now you can do it yourselves. In the interest of time, I think the demo will be more interesting than me talking. So we can sort of gloss over these slides. This is basically a component diagram of what's in SA Engine on the edge. And we do have a couple of engines here, including a neural network inference engine, a computation engine, data stream management system, and a main memory database, including a vector database. You can actually do vector-wise comparisons, which is important in machine learning, for instance. What sets us apart also is this query language, where a user query is written in an extended subset of SQL. Low code. This goes with the interactivity. If you want to be interactive, it should be fast to develop a query. And it should be fast to query your FREEPORT device. So we do have a query language. That query will be optimized like any other database system. So there is a query optimizer which attempts to generate the smartest possible execution plan given a user query. And this is done in interactive time. So in 100 milliseconds, we will have the smartest execution plan possible given your query. In 20 milliseconds more, it will be compiled to the machine code of the target hardware environment. And this is something unique. This was actually difficult.
The rest was simple.
The rest was fairly easy, but this is sort of the magic sauce. So we could talk for a long time about this, but let's keep it short for this time. And then in order to be able to shrink this to very small units, we actually put the cut here and pulled out the query rewriter optimizer compiler from the core kernel, from the runtime. And by doing that, we could sort of separate this small runtime taking up less than 100K to be able to put that on those smallest microcontrollers. Now let's shift gears and talk about federated learning. So how does federated learning fit into our platform and so on? Now that you're familiar with this kind of architectural setup, well, basically what you do first is load and initialize model on the federation services. Perhaps you have a pre-trained model, for instance, that you will want to deploy on all your edge devices. So then you do that on your fleet of edge devices. And then these edge devices will obviously keep training the model. And that is something that you can do within the SA engine using OSQL only. We're also interoperable with, for instance, TensorFlow Lite, if that is available on the edge devices. And then eventually, from time to time, you will want to retrieve weights or other data from the edges and compute federated average or whatever you do. This aggregation model is also configurable by the user. So if you have a preference for anything else than the average, yeah, fine, you can do that too. And then eventually, you will do full cycle and deploy the new edges. I hope I got the details right here. But this is, this is basically how we do the federated learning. So now let's go to the demo. You all heard about the Kungsbacka dataset. So this is the data that we are going to use also in this demo. We will show a couple of interactive queries, including current GPS position, basically asking the bus fleet, where are you now? And we will also ask for ABS events. Does something happen with the braking? Then we actually made a model for ABS system monitoring. So we will deploy that model. Our ABS monitoring model is installed on all the Kungsbacka buses, along with some kind of central storage here. So whenever there is one or more ABS events, those events will be passed to the central storage, and we'll show how to deal with that. We will do clustering both on the buses and in the central storage. So this will be a demo of federated clustering. And the clustering space will obviously be the 2D space of latitude and longitude. Right, and this animation is basically showing what I just said. And yeah, in addition to this federated clustering, we will also transmit geofences based on the clusters, transmit those geofences back to the buses in order to alert the driver. I think that's it.